Hey everyone! So today we're going to talk about our planet's environmental challenges. But here's the thing, it's not just a random list of separate problems. It's all connected. You really have to think of it like a giant, intricate line of dominoes, where one little push in one spot can set off a massive, globe-spanning chain reaction.
And to get us thinking in that mindset, just consider this question for a second. On the surface, it seems pretty straightforward, right? But the answer reveals these incredible, often totally invisible connections that tie our entire planet together. Trust me, by the end of this, you'll see exactly how it all works. All right, let's get into it.
So, where does a story like this even begin? It begins with us. This first part is all about that initial push, that first tap on the very first domino. It's about the fundamental things that we, as humans, do that have completely reshaped the world we live in. And what's really wild is that these four things, building factories, burning fossil fuels, farming on a massive scale, and building huge cities, are literally the engines of our modern civilization. But since the Industrial Revolution, they've been pumping out energy and substances so fast that the planet just can't keep up. These are the core forces knocking our planet's systems out of balance. Okay, so those drivers are the push. What's the immediate result? Well, the very first, most direct consequence is pollution. This is that first domino to actually topple over, the immediate sign that we're overwhelming Earth's natural ability to clean itself. You know, we usually think of pollution as just dirt or trash or grime, but the real definition is so much more powerful. It's about a fundamental disruption. It's when we introduce anything faster than the environment can naturally absorb it, and in doing so, we break its delicate cycles and energy flows. And this pollution gets into the system in two main ways. First, you have what's called point source pollution. Think of a single pipe from a factory or a specific smokestack. You can literally point to it, it's obvious. But then you have non-point source pollution. This is way trickier because it comes from all over, like fertilizer runoff from a huge farm field or all the gunk that washes off a city's streets when it rains. And these sources lead to, well, the whole shebang. We're talking about the obvious stuff like smog in the air from tiny particles and chemicals in our water. But it's also the pesticides and heavy metals in the soil we grow our food in, and the tiny bits of plastic that are now everywhere. And get this, even things like constant, loud noise or excess heat are forms of pollution. These are all those first dominoes, each one making a direct, immediate impact. But of course, the story doesn't stop when one domino falls. Nope, that first domino hits another, which hits another, and on and on. This is the really critical part. This is how a seemingly local problem, like a bit of smoke from one chimney, can snowball into a massive planetary issue. So let's go all the way back to that first question about the factory chimney and the dying forest. This is your answer, acid rain. It starts when power plants and cars release gases like sulfur dioxide. These gases drift up into the atmosphere, cook up there for a while, and chemically transform into acids. Then they fall back down to Earth, sometimes hundreds of miles away. And the result? Damaged forests, lakes too acidic for fish to survive, and it even eats away at stone buildings. A perfect example of a local problem with a long-distance punch. And it's not just in the air. Check out this chain reaction in the water. It's called eutrophication. It all starts with something that seems totally helpful, fertilizer on a farm. But when rain washes that fertilizer into a river, it acts like a super steroid for algae. You get this insane, explosive growth, an algal bloom. But then all that algae dies, sinks, and as it rots, the bacteria doing the cleanup suck literally all the oxygen out of the water, creating these vast dead zones where basically nothing can live. You know, some of the most dangerous chain reactions are the ones you can't even see. It all starts with tiny bits of chemicals like mercury getting into the environment. A small creature absorbs a little bit. That's bioaccumulation. But then a bigger fish eats 100 of those little guys, and a bigger fish eats 10 of those, and so on. The toxin gets more and more concentrated as you go up the food chain. That's biomagnification. And guess who's at the top of a lot of those food chains? We are. So you've got all these different chain reactions happening all over the place. What happens when the whole system starts to buckle under the strain? Well, that brings us to the final, biggest dominoes of all. Two massive, planetary-scale tipping points. And here's the thing you've got to understand. None of this happens in a vacuum. The acid rain, the dead zones, the invisible chemicals, it all adds up. The combined, cumulative weight of all this over decades has pushed two of our planet's most critical systems right to the edge, our global climate and our planet's biodiversity. First, let's look at the climate domino.
Right now, the concentration of carbon dioxide in our atmosphere is over 420 parts per million. Now, that number might not mean much on its own, so for perspective, before the Industrial Revolution, it was around 280. We are in completely uncharted territory, at a level not seen for at least 800,000 years. And the direct result of all that CO2 is, you guessed it, a warmer planet. We're already at about a 1.44 degrees Celsius increase in the global average temperature. And this isn't just some abstract number on a chart. This is the engine that's driving the melting of ice caps, the rise of sea levels, and the crazy extreme weather that we're all starting to experience more and more. And that brings us to the second huge tipping point, the loss of life, of biodiversity. This chart breaks down the biggest threats. As you can see, destroying habitats is still the #1 driver. But look closely. Climate change and pollution, the very domino effects we've been talking about, are right there, playing a huge role in wiping out species at a terrifying rate. It's all connected. Okay, so that's the problem. And yeah, it's critical. It's serious. But the story isn't over. This last part is about how we fight back. It's about how we can intervene in this chain reaction, how we can stick a hand out and stop these dominoes from falling.
One of the most powerful tools we have is simply making rules, legislation. This table is just one example from India, but it shows that for decades we've actually been building legal frameworks to deal with these problems right at the source. From protecting wildlife to controlling water pollution, the basic structures are already in place. And it's not just about laws. We have an amazing and growing toolbox of technologies and strategies. It starts with the basics we all know: reduce, reuse, recycle. But we also have some seriously high-tech solutions, things like catalytic converters on cars that clean exhaust, advanced water treatment plants, and even using microbes to literally eat pollution out of the soil. We know how to stop the damage, and in many cases, we even know how to start fixing it. And that brings us to the final and most important question of all. We have the laws, we have the technology, we understand the chain reactions, and yet the dominoes are still falling. So the real question for every single one of us is this: can we apply these solutions with the speed and the scale that this problem demands? Are we going to be fast enough to win this race against time?